Welcome to Honors Geometry Lesson 2.2, where we talk about conditional statements, the foundation for trying to move away from inductive reasoning to deductive reasoning, which will be a better logical way of thinking for the most part. Not saying that inductive reasoning is bad, it's just that sometimes deductive reasoning is better, at least for what we're going to be doing in geometry anyway, for the most part. Alright, so let's go ahead and talk about conditional statements. A conditional statement is a logical statement that has two parts, an hypothesis, and no, that's not a typo. You're actually, the correct English is to say an hypothesis, and a conclusion. When a conditional statement is written in if-then form, the if part contains the hypothesis, and the then part contains the conclusion. Remember, go ahead and pause this as you need to write things down. In your homework, they're going to ask you to underline the hypothesis. The Tigers win tonight. The conclusion is they are in the playoffs, and you're going to be asked to circle the conclusion. Notice that then and if are not part of the hypothesis and conclusion. They are the key words to let you know that they're coming down the pike. So if tells you here, hey, here comes the hypothesis. Then tells you, hey, here comes the conclusion. And I know some of you are going to mess that up because you're going to want to underline if and circle then. No, not good. Okay, find the hypothesis and conclusion, underline the hypothesis, and circle the conclusion. This is where you're supposed to come up to the board and do this. If the Lions continue to win, then they'll make the playoffs. Oh yeah, that previous example, that's originally for September, so it actually makes sense. This one, underline the Lions continue to win, circle, then they will make the playoffs. Yes. If an agreement is not reached, then the NHL season will be canceled. Well, the first time I made this smartboard presentation, it actually was underline an agreement is not reached. Circle the NHL season will be canceled. That's what's circled. Alright, sometimes if-then statements don't always come as if-then statements. Some conditional statements are not written that way, and we'll have to change them. Oh boy, if you can hear that beeping, that means the cookies are ready, so at any time I may pause this and go jump and get one. Okay. Write this statement in if-then form. It already has an if in it, so all we're going to do is change the order of it. If, and we can't start off a sentence with they because there's no antecedent. So we're going to have to say what those if that they is. If two angles are a linear pair, then they are supplementary. Okay, anytime you see a when, think if. Pretty easy to translate. If x equals 4, then x squared equals 16. Anytime you see a because, think if. If n equals 4, then 5n minus 2 equals 18. Now there are some other conditional statements that don't even have an if or a because or anything like that. Let me show you. All straight angles have a measure of 180 degrees. all or every. This is the way you're going to do it. If. What are we talking about here? Angles. If an angle is straight, then it has a measure of 180 degrees. Every visitor to ground zero is in New York City. If, what are we talking about? Visitors. If a person, no, we could say visitor actually. If a visitor is at ground zero, then don't say they because it's only one person, a visitor, then that person is in New York City. No mammals have scales. Now the no, if a statement starts out with a no, this is the way you're going to do it. If an animal is a mammal, here's where the not's going to come into play. If an animal is a mammal, you can't just say, you got to start off with something. So you can't say if it is a mammal. No, if an animal is a mammal, comma, then it does not have scales. So this no is actually going, stupid eraser. This no is actually going to be negated, or you're going to use that negative part in the conclusion. That's where that no will end up going, in the conclusion part. And off the bat, I can think of two mammals that are good counterexamples because they have scales. Armadillo is a mammal, but it has scales. And then one of my favorite mammals that has scales is a pangolin. You don't know what it is? Go ahead and look it up. They're really cute. Moving right along, negation is the negative of the original statement. Example 1, the ball is red. The negation of that statement is the ball is not red. Example 2, the cat is not black. The negation is the cat is black. If there's a not in there, take it out and that'll negate it. To write the converse of a statement, switch the hypothesis and conclusion of the original. To make the inverse, negate both the hypothesis and the conclusion. And to make the contrapositive, write the converse and then negate both the hypothesis and conclusion. Go ahead and pause that as you need to, because I know you're not going to write it down as fast as I say it. Alright, original statement. Guitar players are musicians. So if you are a guitar player, then you are a musician. Converse, if you are a musician, then you are a guitar player. I've switched the hypothesis and the conclusion. The inverse, if you are not a guitar player, then you are not a musician. I've negated both the hypothesis and conclusion. That's how you make the inverse. And the contrapositive, look at the converse and negate it. If you are not a musician, then you are not a guitar player. Alright, and let's go ahead and look at the truth values of these statements. If you are a guitar player, you are a musician. Is that true or false? Well, I know my grandfather would probably argue with you, and he would say, if he were still alive, no, guitar players are not musicians. But yeah, that's true. Okay, if you are a musician, then you are a guitar player? Well, that's false. What about all those oboe players out there? You can play an oboe and be a musician, but you're not a guitar player. How about if you're not a guitar player, then you're not a musician? I'll use the oboe example again. Okay, that proves that this statement is false. And the contrapositive says, if you're not a musician, then you're not a guitar player. That's true. Okay, I just showed you these examples and their truth values to show you that the original and the contrapositive and the inverse and the converse will always be the same truth value. Now, it might be that all four statements are true. It could possibly be that all four statements are false. But the original and the contrapositive will always be the same. If they're all true, well, they'd still be the same. And the inverse and the converse are always going to be the same. A biconditional statement. Any conditional statement that is true and has a true converse can be written as a biconditional. A biconditional statement can be written using the phrase if and only if. All definitions in geometry can be written as biconditionals. And let me go ahead and show you an example. Here's a definition of right angles. All right angles have a measure of 90 degrees. That's the definition of right angles. Here is it written in if-then form. If an angle is a right angle, then it has a measure of 90. The converse, if an angle measures 90, then it's a right angle. See, I switched the hypothesis and the conclusion. That's right. That's how you make a converse. And then the biconditional. An angle is right, or is a right angle, if and only if it measures 90 degrees. So you put that if and only if in front of the first hypothesis and after the first conclusion. And before the first conclusion. And that's how you make a biconditional. This will conclude Honors Geometry 2.2 Conditional Statements.